the point, the list doesn't compute size as things are added, but some of the other STL structures do keep an updated size. So vector, for instance.
The boost library, okay, so we use boost before. So the boost library accepts any type of concept. So in this case, the representation that was used for the adjacency list was a standard list. You can pass in any of the others
Sure.
as well.
Well, I was just saying, if people are curious, that if there are other size updating structures there.
But I bet you though that the author of this code wouldn't be using those because they wouldn't want to pay that price. Would be my guess. So that's an example where you have an efficiency problem, and the only way to solve it is to get your make the actual runtime complexity of the implementation match the algorithmic complexity of the underlying graph algorithm. Right? Graph algorithm here is I think it's ON log n, not entirely certain. And if your implementation is ON squared, it will not finish. You have to make sure that matches. Yeah, so this is my GPROF example. What I'm planning on doing is for the new class I'm teaching in the fall to take some of these examples, like this example and the other example about the Fortran code, and turning them into student exercises. Okay, where I would essentially give students this code, so this is the code, and we've been approached by a researcher, and the researcher says, my code doesn't finish, my code gets stuck. Okay, now do something, right? And then use those tools to, using those tools, use a systematic approach to eliminating possible sources of possible reasons for what the problem could be, and then suggest a solution. By the way, the other problem that with the Fortran code, okay, that didn't finish, that problem had to do with machine position, and it turned out that the problem was in this file. Okay. And in this file, the Fortran code defines the machine constants. The machine constants were defined for Spark. And this code had been ported from Sun to a Linux machine. It was running just fine on the Sun machine. It didn't run on the Linux machine. Why not? Because Linux is an x86 architecture. Now, the somewhat ironic, are we still being recorded? Am I still being recorded?
You're out of time.
Okay. Somewhat ironic part here is that this code is, if you look at it, it is from, let's say here, it is from, it's from 1980 basically, and that's why there was no support for x86 because it didn't exist.
It says Intel 8087.
Intel, yeah, this one. So 386 didn't exist. So they also IEEE 745 wasn't there. Newer version of that code had that. But they have information for the PDB-11 goes 5700, and so.